Here we're given a graph. It's an angular sort of graph, and it begins at x equals -2 and it ends at x equals 5. The lowest point on this graph is y equals 1, and the highest point is y equals 4. And what they want you to do is find the open intervals of increase, decrease, and constant intervals, and then they want you to find the domain and the range. So let's find the intervals of x values upon which the function is decreasing. I like to imagine that I'm a little ant climbing along from left to right, down, up, across. For what values of x on the x value, on the x-axis, is the little ant going downhill? That would be the intervals of decrease. It occurs from x equals -2 all the way down to x equals 1. On that interval of x values, that little ant is going downhill. So the function is decreasing as we move from left to right. The function is decreasing on the x interval from -2, comma, to 1. And I ask for open intervals, so just make sure you put open parentheses. You don't need boxy brackets. Now, increasing. Well, the little ant turns around and starts crawling uphill from x equals 1 to x equals 2. You see how he's climbing uphill? So we have an increasing function on the open interval of x values from x equals 1 to x equals 2. And what about constant? Constant means he's not going uphill or downhill, and that occurs from x equals 2 all the way across until x equals 5. He's going straight across. In other words, he's constant. So this function is constant on the open interval of x values from 2 to 5. Now, as far as the domain and the range, the domain are all possible x values. They start at -2, they end at 5, and they include -2 with a solid dot. They include 5 with a solid dot, so they're boxy brackets on both ends from -2 to 5. The range, all possible y values. The smallest one occurs at y equals 1. The highest one occurs at y equals 4. We have solid circles in both locations, which means we use boxy brackets on both of them from 1 to 4.